Okay, hi, and welcome back. This is our first set of content, real short to start with, and just a little bit of an experiment in thinking, really. So, the first thing I always ask students about biology is what do you think are the most unifying concepts in biology? And I actually want people to make a list when they do this. So, in a moment, I'm gonna ask you to make a list, and when you do that, you just pause the video and make your list, and then start it again after you've made your list. It's really important that when I ask you to do these things in these recordings, you actually stop and you do them. If you don't, then your brain's not going to do any work and no learning occurs. So kind of important here are two words. One is unifying and the other is concepts. So something that's unifying brings everything together. What is the biological principle that just brings everything together, that kind of wraps everything up, that helps us understand the subject that we're studying? So that's what unifying means. So a concept is not a fact or a topic or a small field of biology. And so sometimes I ask students this question. I say things like genetics. Genetics is a unifying concept. Well, genetics isn't a concept. The law of thermodynamics is a concept. It's used multiple places, and it's broad-reaching, and it's a law. So it's maybe not the best example. So what I want you to do is actually pause the video now and make a list. It could just be 2 or 3 things, but make a ranked list. So the top one, make it the most unifying, and the bottom one least unifying. So make a list of the most unifying concepts in biology, and then you can start the video up. So I'll pause a moment, and you can stop the video. Okay, hopefully you've made a list of the most unifying concepts in biology, and it may be a little bit of a leading question. You may know where I'm going with this. So let's kind of have a little bit of a mind game here, a little bit of cognitive gymnastics, I guess. So let's start with this question. If I sat you down in my office and we had a chat, and I said, "Do you believe in evolution?" How would you answer that? And I'm a biologist. Of course, I believe in evolution. That's so important in biology. But so okay, yes, I believe in evolution. So okay, let's kind of take the next question that I've got here. How about climate change? What would you say if I said to you, "Do you believe in climate change?" What would your answer be to that? And then what about if I said to you, how about gravity? Do you believe in gravity? And that seems a bit stupid, doesn't it, really, to ask somebody whether they believe in gravity, because if I push you over, you hit the ground. So that's a bit of a stupid question, but let's consider it anyway. What about blue? Do you believe in blue? Again, it's a bit stupid. It's a color. It's blue. It's due to the nature of light wavelengths being reflected and absorbed. So the last 2 questions are a bit stupid. Nobody believes or doesn't believe in the color blue, and nobody believes or doesn't believe in gravity. You may debate gravitational theory, but you don't disbelieve in gravity. So the point is, I'm asking the wrong question. When people come up to you and say, "Do you believe in evolution?" it's like asking whether you believe in the color blue. Nobody would ask if you believe in the color blue. And so the point here, I think, is science is not about belief. When people ask you whether you believe in something, they're asking you to make a statement about the universe based on literally on a belief system, and belief systems generally lack evidence. Science is about empirical observation. It's about careful experimentation. It's about deductive and inductive reasoning. It's about principled reasoning. And so when people ask you, "Do you believe in evolution?" is what they should really be asking you is, have you evaluated the evidence that exists that supports the theory of evolution? That's a much better question. So in response to that question, I say, absolutely, I've evaluated the evidence, and there's enough evidence there, and it's strong enough, and it's robust, and it's consistent, that I accept the theory of evolution as being correct and truthful. If you ask me if I believe about gravity, of course I believe in gravity. If you push me over, I'm going to fall over and smash my nose into the concrete, which is something you may actually enjoy seeing by the time we get to the end of the semester. But asking about belief in science is wrong. So when people ask you about, "Do you believe in this? Do you believe in that?" in relation to biology, you need to correct their they're questioning. And so if you ask me, what is the unifying concept? Evolution is the unifying concept in biology. Famous scientist who we'll talk about next time had a phrase something along the lines of how everything in biology should be looked at through the lens of evolution. And I only bring evolution up in General Biology 1, which is concerned with cells and molecules and that kind of stuff, because even at that level, we have to have an understanding of evolution. So next time we'll take a look at evolution, and we'll compare Darwinian and Lamarckian evolution and talk about that a little bit more. So that was just a little bit of cognitive gymnastics to start with, but something interesting and important to think about when people ask you, do you believe in this, do you believe in that, do you believe in evolution, do you believe in climate change? Wrong question.